I am continuing on the lecture which I left previously. I had to take a break to bring these samples. Now, please have a look at this sample again one more time. If you remember, I briefly showed you this unit. Okay. This unit has a Peltier what do you call module fitted inside. There is a cold side and there is a hot side, then we have a fan here. So, and in general we are all familiar with these what to tell these Peltier things to be used for cooling. Now, we come to the next important thing. If you look at the this what do you call information that is what do you call available freely on the web, Laird is one of the so many of the people who keep stuff related to these modules on hand. So, we could get our hands on 2 of these modules. You see this here, and in keeping with the best tradition, we burned this first. I do not know what went wrong, we burnt it, and then after the burning was over, we decided that since we have 2 more pieces, we will read the manual. Up front, if you read the manual, it means you are giving up and admitting the other fellow is somehow endowed with a bigger brain. So, now coming back, that led us to all this information which I have here, kindly have a look. So, typically how we have all this what do you call beautiful you can read it yourself. Standard finishing to accommodate alternate lead lengths, lapping thickness and moisture protective sealants, pre-tinning and solder constructions to accommodate and so on, and a huge what do you call generally a map is given here saying as we want the more and more temperature differential and so on and so on, what is the operating things we would like to have and so on. So, typically if you go here, we have all these what do you call catalogs which will show the type of modules that are available. So, I will go here. This is the module we managed to pick up. This is the CP series, and typically we have 15 by 15 small module, and then it will give you details of what is the delta T, and then what is the maximum current, and then what is the maximum power that we can use for a small thing. Just wanted to show you typically we have all these what do you call things. Now, I will go on to a big catalog here shows CP ceramic plate is considered the standard in the thermoelectric industry, meaning everybody seems to use these things. So, you have a lot of thing about what is the power that has to be that needs to be cooled, then the temperature difference, and by difference by it looks like by some standard typically around 60 degrees a little around 60 degrees seems to be the limit, you do not have it much higher than that. Then we have the what do you call length and through width, typically this 30 by 30 and these things. I think we have used this CP10 30 by 30, that is the one you have here. CP10 127 30 by 30 is the module I have here. So, 30 mm square, and then the thickness is some, it says 3.6, I think we can believe the catalog. So, the having selected one of them, you see we have all these things here. You, if you want to know more about it, you just need to click down. Oh, I think we have seen this already. You notice here about 67 is given here and dimensions 30 by 30, and then the thickness is a little small. Typically, the surface finish pre-tinning hot and or cold phase with 180 degrees what do you call solder, and so on and so on, all the details are given here, and the application is also given here. Bismuth telluride semiconductor material and aluminum oxide ceramics, and we have data sheets related to this are also mentioned here. I will just try to open that. See that this is a application saying it is used for medical lasers, lab science instrumentation, and thickness prior to tinning, delta C and all those things, and then the subsequent picture gives us the actual useful application note. One of them you see down here is the voltage, the applied voltage gives you the what do you call the range at which what is the delta T you can obtain, and then the QC versus this figure. No, as you have lesser temperature, more wattage can be given, and if you have what do you call more temperature difference, the lesser wattage will take place in that, which is you need to look up on this table, then decide on the voltage that gets applied like this. So, the next level is we have ready made units like this here. Can you see here a small unit here? I will see if it connects to the internet directly. We are lucky, maybe we will be able to see this. This is what we have tried to replicate here. You see here, we try to replicate here, because our interest is not to purchase this unit directly. We could have also purchased it, but we notice that with our fan, and you see here this is direct impingement, meaning the fan is fitted here. In our case, we wanted it to flow across like this because of some considerations. Then most important is this is the what do you call biomedical device, in which we have to put a test tube inside, and the test tube has the specimen, the thing which is we need to quickly heat it and cool it. It has something to do with human gonadotropin, those things related to some what do you call study in immunology assay. And why it is open both sides is that we needed to put some instrumentation, including some UV lighting and sensors and all that, and this is not the way it is intended to be used, because there will be tremendous short circuit between the cold and hot. So, it has a cap which fully seals it, and this cap one side we have a place to provide our what do you call samples. They are test tubes with a special bore on it. Other side it has all the other things. We are saying this insulated cap, that is the one gives us the advantage of making sure that this cold side stays cold and it does not get warm by ambient. If somebody attempts to just take a device like this, and then expects it to cool, it will not cool. But for simple very small things, and then if you want to demonstrate or you are using sensors, obviously we have a range of small heat sinks and all which our people have fabricated. You see here, I have a small heat sink here, it is attached to this. Do not ask me why it is and why this is made. This is actually made for some other power device which is taken from a printed circuit board, and then something else is attached here, and then we have varying types of these assemblies which we have tried. Yeah, you must be saying, is it a lot of unnecessary trial? A little and a little not, like this. Our idea being, without having to go for very elaborate what do you call this, fans and convective cooling and all that, is it possible for us to make a simpler way of handling these things? So, if you see, if you go to these what do you call data sheets, we have very interesting thing. Have you noticed? Oh, we have something which seems to have a fan on this side and a fan on this side also, and what you will notice is no insulation anywhere. So, what is the reason for such a what do you call, obviously something which beats the whole thing of what I was talking about. So, you can read it for yourself. Typically, these are mounted across a wall. If you have a wall, inside you have a space. So, you have what you call hot air coming out one side and cooled air coming out one side, depending on which way you want it. You can now use this air to fill up a space you want. So, if you have a small area which you need to cool, so it is possible for us again one more time the what you call total watts versus the temperature difference performance curves are given here, and there are two clear, a warm side and a cold side. Me being a little what you call nitpicker, this is not an isometric drawing, it is basically a 3-view drawing with 2 views shown here. The idea being, if you put it in a enclosed space, meaning you have a box here, and I mean if you keep the box here, inside the box become cold and this time becomes warm outside, and you can play around and see what best you can do with the application that is provided here. Oh, I will come back to this later. Obviously, one of the advantages is it is reversible. Have you noticed it? Only for sort of making making it extremely simple. They have put 150 here and they have put a 230 here and 80 here. So, obviously, this 150 plus this 80 will give you this thing. I mean you can take it as you like, and happily they have reversed. By reversing it you get 80 watt cooling power, but then you see very interesting thing here. To get a 80 watt cooling power here, you are not just sending out 80 watts outside. This is why I showed you this figure, because inherently other than the 80 watts is total 150 watts of various losses are there in this. So, something like 3 times the amount of heat you will be expending and then same this 230 watts equivalent, I am sorry 150 watts equivalent electrical energy. If you want to cool 80 watts, twice of that much of electricity, you see 80 watts cooling, and then you end up with having twice as much electrical energy to be pumped into that. This is a little bit of the trade off when we are using it, but the main advantage is reversible. So, in this case you can cool it, and if you want it you can heat it, which is exactly the reason why we have started our sample with those things. I hope I have made something clear. Those of you who are curious can go to Instructables. Instructables has given a fantastic portable air conditioner, uses a Peltier as a cooling mechanism and some cooling fans for blowing air. It is good as a novelty, as an experiment, but I feel a little let down when I see that some big corporate has gone about promoting it, saying this is the answer to India's air conditioning and refrigeration work. So, well, I have no comment on their what they call positioning statement. I do not think it has been thoroughly calculated. Compared to that, if you take a small new 3 and 4 star compressor type refrigerators, which you would like to see in probably you will see in your wine coolers and all that, they work better. I will just stop there. You need to design those things. So, Instructables has given a beautiful nice thing. Any of you are curious and have taken this, I am sure that is how you are reading all this. I suggest you try it out. So, the way heat sink, there are 2 types of heat sinks, and then eventually you see this white stuff, that is the thermoelectric stuff, and then what they have done is they have made a cabinet like thing. So, air comes here and goes out. Okay. So, this part of it is the whichever it is, the part which you want to, this is the hot side, and the cool side, the ambient air inside your cabinet or inside your room is taken, and then cold air is thrown out, hot air is thrown here, and it is fully reversible. It is a small novelty item, it is very, very useful for you. Sir, if you can show me this again. I have 2 modules here, can you see? I have these 2 Peltier modules. Show this, sir. We come to the next interesting aspect. If you have to keep them parallel like this, meaning parallel in the thermal way, that is you keep a hot, cold, okay, I'll keep a hot thing this side and the cold thing this side, okay, rather hot this side and cold this side. These are running in parallel. More cooling capacity can be brought about, that Q more can be brought about, and we can keep it in series. When we keep it in series, leave out the electrical thing at the mind. When we keep it in series, you have one, let us say, hot surface, cold, again cold to hot, again cold surface. So, you get a much better temperature differential here. These things are also built there, and in one of in their catalogs they have given it. So, it is for you to go about trying to do how to mount these things. So, he has happily given some epoxy thing and all that. Not very good, because the conductivity is not good. You need to put a proper bonding compound, high conductivity bonding compound is available. Connect the heat sinks together, copper paste you see here very nicely, very properly he has given. No, if you can get a loaded copper paste like thing, it will be much better. Then you attach the fans, and then in the end you can have a beautifully done thing. What it looks like, he has given a schematic, how to use it. Of course, it is for you to decide on, He says you take a tube and then you throw out the air from the window, and then just read the thing as a novelty aspect. What do you call improving the whole system? Yes, there are modules which are, you see, directly stacked here. Can you see? Two modules are stacked together. I will just click on it and I hope it opens. If you are lucky, yeah. Yeah, I think it is opening, slowly it will open. Oh, something very unusual. How come both are, I mean all of them are not of the same size? They are obviously not of the same size. Why? And here they both seem to be of the same size. So, having calculated the whole or some settings here, I am not able to reach it. By yourself you can read it. What has been done here is, depending on the what do you call physical configuration, two of them directly you can just like what I have shown you here, no, you can put them in series. Then they will notice that more and more area is required because temperature differential is not sufficient. So, the area that is required for transfer has to be increased, and total Q has to be handled. Hence, this type of configurations require better way of operating these things. Now we come to, do we stop there? See a very interesting thing. Why just stop at one face? Why not we put it in all the faces? There are some here who have tried putting it in all the 4 faces. So, you have 4 thermoelectric Peltier modules here, and then you have heat sinks attached here, and the main advantage for it is, if you now put a fan all around it and you see the profile of these fins, you probably get the best efficiency on how well you can throw away the heat. I wanted to show you exactly for this. So, it is for us to now play around with it, and now do we have to stop here, and then what happens to the corner here? This is where your innovativeness comes, and see best. And obviously you can't have this, but it is very much possible that you have 1 or 2 more fins fitted here, but this base is not there for you to transfer the heat. So, this is typically what is done for various types of sorry. Yeah. If you go back to the beginning, you have various types in each of these what do you call systems. The application notes and how you make it are all clearly explained here, saying you have things which are kept in series, then you have things which different type of things you have seen here. 2 steps, sizes are small. Some reason I am not able to open it, but you can go to this layered tech and then see what best you can do. So, my point is, it is essential for you to play around with this. Now, are there any practical applications? Yes. I will draw your notice to my favorite this thing. I am sure quite a lot of you have seen this. USB. I am sure you too would have noticed that this probably these slots, these USB what do you call sockets obviously cannot give 500 out from computer and 500 into 4. This beats the whole physics as we know it. So, it has also a place for giving a 5 volt DC externally. If you give this 5 volts DC externally, it can support 2 watts, that is actually 500 I am sorry 2 amps for this, plus a small heater which is there here. Now, this heater happily is giving me warm tea. I heat it, bring it here, and then if I have that what is equivalent to a tea cozy, I keep it, or I am sure a lot of you people have the coffee or teapot, which is insulated teapot. At the bottom, if you have an access to this directly, you can have a tea which you can stay there and you can steep the tea as you like. Initial tea will be all right and so on like that. Now, I come to the advantage of having a, imagine this is replaced by a Peltier. You know what we have. You can have a cold drink. Oh, I do not want to use the word fizz, I do not want to use the word soda, I do not want to use the word, we have unmentionable low alcoholic beverage, but then you know what it is we are all talking about. It is possible for us now to have a portable cooling device. So, I will try my luck on the internet now saying you must have seen these ads everywhere. Okay. So, we have an apple and then I see that there is a blue colored something, a green colored and probably a red colored, whole thing is insulated. They call it a mini refrigerator. The issue being you can't really cool anything, you understand, but can keep it cold by switching it on.